So we start by considering a circle, and then we will be considering a point P that lies on this circle. Let's draw a line that passes through the point P. Let's say we have the line PT, which is passing through the point P that lies on the circle. We're going to name this line as the limiting line. We'll come to this in a moment, why we are considering PT as the limiting line. So let us consider another point Q that lies on the same circle. Here we'll make an assumption that this point P, let's say for the time being, we're going to keep it fixed. So this is a fixed point P, whereas the Q is going to be a moving point. Now what we'll do, we'll draw a line which passes through the point P and Q. So we have the line which passes through the point P and Q, and this line PQ is referred to as the secant line. Now what we'll do, we'll keep the point P fixed, and then we are going to move the point Q clockwise and such that it is at a new position. Let's call it the point Q1. Now what we'll do, we'll draw another line that passes through the point P and the new point Q1. So we get another secant line that passes through the point P and Q1. Again, we are going to move that point to a new position Q2. So our goal is to move the point Q clockwise such that it goes closer and closer to the point P. So we can get another point Q3. As we can clearly observe here that the next point that we choose is going to be more closer to point P. Let's say Q4 will be more closer to point P, and there will be a time when Q4, the point Q, is going to coincide with the point P, and in that case the secant line PQ is going to be coinciding with the limiting line PT. As the point Q approaches point P, the limiting position PT, or can say the limiting line PT of the secant line PQ, is going to be referred to as the tangent line to the circle at the point P. So this is how we can define the tangent to a circle. Hence, the tangent at a point P is the limiting position of a secant line PQ when the point Q tends to a point P along the circle. The point P is referred to as the point of contact of the tangent. So now that we have defined the tangent to a circle at a given point, the next task will be to define the equation of the tangent line. So there are several ways to define the equations of a tangent line. That means equation of a tangent line can have different forms. So we'll start with the first one, which is referred to as the slope form of the tangent line. Slope form of a tangent line. The equation of a tangent line of slope m to the circle x squared plus y squared equals to r squared is given by this expression y equals to mx plus o minus r times square root of 1 plus m squared. And the coordinates of the point of contact are defined as given here. So let's try to derive this formula. So we will consider a circle with center at C. It's given here that the equation of the circle is x squared plus y squared equals to r squared. So if we compare this with the standard form of a circle, which is given by x minus h whole squared plus y minus k whole squared equals to r squared, then we can immediately define the coordinates of a center. So the coordinates of the center, which is given by the coordinates h comma k, that's going to be 0 comma 0, meaning our circle is centered at the origin 0 comma 0, and the radius of this particular circle is going to be equals to r units. Now what we'll do, we'll consider that the equation of the line which touches the circle be given by y equals to mx plus c. Now here c represents the y-intercept of the line. Now what we'll do, well, we will drop a perpendicular from the center of the circle to the tangent line, and let's say it meets the tangent line at the point A. Now what we can do, we can find out the distance of the point C from the straight line A. Now what we'll do, we'll rewrite the equation of the line in the standard form, that is ax plus by plus c equals to 0. So we're going to get m times x minus y plus c equals to 0. Now the reason why we're doing this, because we know that if we have any point, let's say x comma y, which is from a certain line whose equation is given by ax plus by plus c equals to 0, then the distance of this point from the straight line will be given by the absolute value of a times x plus, let's call it x1 and y1 to avoid confusion, ax1 plus by1 plus c divided by the square root of a squared plus b squared. So using this particular idea, we can define the distance of point A from the straight line. So that will be CA, that's given by the absolute value. Now what we'll do, we'll take the coefficient of x of the straight line, so that's m, that will get multiplied to the x coordinate of the center C. So we'll have m times 0 added to, we'll take the coefficient of y, which is -1, and multiply with the y coordinate of C. So that's 0 plus the constant term C divided by the square root of 1 plus, we have 1 plus m squared. Okay. Now what's CA? From the diagram here, CA is nothing but the radius of the circle. So we can say that this absolute value must be also equals to the radius. Now we get C over square root of 1 plus m squared equals to r, or we can say that absolute value of C will be equals to r times the absolute value of the square root of m squared. If we get rid of the absolute value, this C value will be equals to plus or minus r times the square root of m squared. So now we obtain the C, which is the y-intercept of the line. This is the line. So we earlier assumed that this equation, let it be given by y equals to mx plus c. Now what we'll do, replace the value of C with plus or minus the radius times square root of 1 plus m squared, and this becomes the equation of the tangent line. So here we have used the slope-intercept form of a line. So this y equals to mx, this is defined as the slope-intercept form of a line. So that's why this particular equation, which is similar to the slope-intercept form of a line, it's referred to as the slope form of the tangent of the line. Now the next goal will be to find out the coordinates of the point A. Now to find out the coordinates of point A, all we have to do is take the equation of the circle, which is x squared plus y squared equals to r squared, and take the equation of the tangent line, which is y equals to mx plus or minus r times square root of 1 plus m squared. We solve these two equations simultaneously. We solve these two equations to obtain the values of x and y. That's a very simple task. All you have to do is replace the value of y with mx plus or minus r times square root of 1 plus m squared. That I'm leaving as an exercise for you to try out, and you can confirm that its value is going to be, the x coordinate will be plus or minus m times r divided by square root of 1 plus m squared, and the y coordinate will be negative minus or plus r times r over square root of 1 plus m squared. Now this sign plus or minus, minus or plus, that means that if the x coordinate is a positive value, then the y coordinate is going to give us a negative value, and if the x coordinate is negative, then y will be positive. Okay, so now we have found out the slope form of a tangent line. So there is another form which will also give us the equation of the tangent line, that's referred to as the point form of the tangent line. So we'll try to find out the point form of a tangent line. Now, if you recall, we have a straight line. Let's say the straight line has a slope of m, and it passes through a point x1 comma y1. Then the point form of a line is given by the equation y minus y1 equals to the slope m times x minus x1. So we're going to use this particular equation to represent the equation of the tangent line. So here we again have a circle. Now this time we're going to consider the general equation of a circle, which is given by the equation x squared plus y squared plus 2gx plus 2 times fy plus c equals to 0. Now this circle has the center at C with coordinates negative g comma negative f. Okay, now let's say this is the point P having the coordinates x1 comma y1. Now what we'll do, we'll consider another point on the same circle, and we're going to name it point Q, with the coordinates x2 comma y2. Now these 2 points are going to lie in the circle, and since they lie on the circle, it's going to satisfy the equation of the circle. So that means for point P, x1 comma y1, the equation of the circle will be x1 squared plus y1 squared plus 2gx1 plus 2 times f times y1 plus c equals to 0. Fine. And then for the point Q, having the coordinates x2 comma y2, this is going to satisfy the equation of the circle. So we have x2 squared plus y2 squared plus 2gx2 plus 2 times f times y2 plus c equals to 0. Let's label this as equation 1 and equation 2. What we'll do now, we'll subtract equation 2 from equation 1. That's going to give us x1 squared minus x2 squared plus y1 squared minus y2 squared plus 2 times g multiplied to x1 minus x2 plus 2 times f multiplied to y1 minus y2 equals to 0. So here we have the difference of two squares, x1 squared minus x2 squared. So that's simply x1 minus x2 times x1 plus x2. And then we're going to take the next term as 2g times x1 minus x2. Similarly, we can factorize the difference of the two squares, y1 squared minus y2 squared. That's going to give us y1 minus y2 times y1 plus y2. And the next term will be 2 times f times y1 minus y2 equals to 0. So from these two terms, let's take x1 minus x2 as the common factor. Now this will get multiplied to x1 plus x2 plus 2g added to, now we will take y1 minus y2 as the common factor. So that will get multiplied to y1 plus y2 plus 2f equals to 0. Fine. So here, if we rearrange the terms, we get the expression y2 minus y1 divided by x2 minus x1. So that will be equals to negative times, we'll have x1 plus x2 plus 2g divided by y1 plus y2 plus 2 times f. Okay, so we're going to label this as equation number 3. Now, by definition, this is nothing but the slope of the line which is formed by joining the points P and Q. So if we join P and Q, the slope of that particular line is going to be the expression that we just obtained as given in equation number 3. However, if we extend the line through P and Q, this is nothing but the secant line. We've already talked about it. This is the secant line. Now, what we'll do, we'll try to make, because we want to find out the equation of the tangent line. So what we'll do, we'll make the point Q move towards point P. So that means we will let the point Q move towards point P, which simply means that x2 is going to approach x1, and then y2 is also going to approach y1. All we have to do is replace the value of x2 with x1 and the value of y2 with y1. So on equation number 3, in equation number 3, the left hand side is nothing but the slope m, and then we have the expression x1 added to x2, but x2, that is simply x1, so we have 2 times x1 added to 2 times z divided by 2 times y1 plus 2 times f. That means our slope value comes out to be negative of x1 plus g divided by y1 plus f. Fine. So we have obtained the slope of the line. Now, in order to find out the equation of the tangent line, we need the point P, the coordinates of point P, that's x1 comma y1, and we have obtained the slope of the tangent line. Of course, we've started by finding out the slope of the secant line, but we considered that Q, when it approaches P, we can also define the slope of the tangent line. So we'll use this particular expression. That means the equation of the tangent line is going to be y minus y1 equals to the slope. The slope will be negative times x1 plus g divided by y1 plus f multiplied to x minus x1. So let's further simplify. We have x1 plus g times x minus x1 added to y1 plus f multiplied to y minus y1 equals to 0. Let's expand it. We're going to get x times x1 minus x1 squared plus g times x minus g times x1 plus y1 times y times y1 y times y1 minus y1 squared plus f times y minus f times y1 equals to 0. Fine. Now let's further simplify this. We're going to get x times x1, this is done, plus y times y1, this is also done. Added to, we have gx here. So what we'll do, we'll take gx as it is, and we're going to rewrite negative gx1 as positive gx1 minus 2gx1. Then we have gx is taken care of. Next we have fy. So we have fy. So we're going to rewrite negative fy as positive f times y1 minus 2 times fy1. And then we have negative x1 squared negative y1 squared equals to 0. So here we get x1 plus y times y1 plus g times x plus x1 plus f times y plus y1. And then we have, let's add positive c and subtract negative c from it. The reason why we are doing these extra terms, now what we can do, we combine all the leftover terms. So we have negative x1 squared, negative y1 squared, then we have negative 2gx1 minus negative 2fy1 equals to 0. So if we take negative as the common factor, so we have c plus y1 x1 squared plus y1 squared plus 2gx1 plus 2fy1, and this expression is equals to 0. We have already defined for the point P. So this is equation number 1. This is equals to 0. So this entire expression goes to 0. So we are finally left with the equation of the tangent x1 plus y times y1 plus g times x plus x1 added to f times y plus y1 plus c equals to 0. And this is going to be the equation of the tangent line, which is tangent to the circle at point P. And we've used the general equation of the circle, and this is also referred to as the point form of the tangent line.